So reviewing what we did yesterday, we saw SOHCAHTOA for the first time, and this is an acronym that helps us remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We're going to be using that again today. And then the other thing we need to remember is that from this designated angle, the side opposite it is called the opposite side, and we abbreviate it as O. Then this side, the longest side right here, is called the hypotenuse, and we label that H. And then the side that's left over is the adjacent side. It's right next to theta, or the designated angle. And that's what we need to remember for today. So over here, on this first page, we're just going to focus on the setup of the problem, still not plugging anything into the calculator. And then on the next page, I'll show you how to plug stuff into the calculator. So for this one, this first example problem is where we're going to start. And we're going to practice the same thing like 3 or 4 times. So if you don't quite get it the first time, like just hang in there. So on this triangle, you have one angle that's labeled. That is your designated angle, like your theta or your x. That's the angle that you want to focus on. Then from there, you have 2 sides that are labeled. So you have this that's labeled 8, that is your hypotenuse, and then this is your adjacent side. So that's what you have to work with. So you have A and H to work with, and then you have to decide whether you can use sine, cosine, or tangent. So I'm looking for the one with an A and an H, and that's this one. So that means I'm going to use cosine to solve this problem. So cosine 65 degrees equals A over H, which is going to be x over 8. Okay, now we're going to do that a few more times. So for this one, again, I'm using SOHCAHTOA each time, KAHTOA, and SOHCAHTOA. Once we get good at this, you don't have to write it every single time. You'll just have it as like a reference point. We'll just write it for now. Okay, so for this first one, we have a designated angle, and then we're determining which sides we have. So we have the opposite side and the hypotenuse. And then based on that, we're deciding whether we need sine, cosine, or tangent. And sine has opposite and hypotenuse, so we're going to use this one. So we do sine of 61 degrees equals opposite over hypotenuse, so be 24 over x. Okay, and then the next one, repeating the process, we have our designated angle right here, and then based on that angle, we have the hypotenuse and the adjacent side. So we have to figure out whether we use sine, cosine, or tangent, and cosine has the A and the H, so we're going to use this one. So cosine of 27 equals adjacent over hypotenuse. Remember that order matters. Look at this. And then for the next one, we have a designated angle, opposite and adjacent. So O and A, we're going to use this one, which is tangent. So tan of 52 equals x over 13. Got the setup. Okay, so on the next page, we're going to continue doing the same thing. Okay, so write SOHCAHTOA because you still, and even though I've been teaching this a long time, I still have to write that to reference it, just to make sure I don't mess up. Okay, so what we're going to do is continue with that same setup. We have our designated angle here, and then based on the angle, we have opposite and hypotenuse. So with O and H, we're going to use sine. sine of 59 equals opposite over hypotenuse. Okay. No, now we're gonna solve. Okay, so now to solve it, we need to get d by itself. So we multiply both sides by 37. This cancels, we get 37 sine 59 equals d. And now the point is when we break out the calculator. Where'd my, I swear I went over there to grab a calculator. I already shot a calculator on the desk. First things first, make sure that your calculator is in the right setting. It should be in degrees, so make sure that it says degrees right there. If you're ever not getting the right answer, it might be in the wrong setting. And if you hit this, it goes to radians and grad. I don't know what grad is, but degrees, radians, and grad, it needs to be on degrees. Sometimes the Google calculator, if you're used to using Google calculator, defaults to radians. Make sure it's on degrees so that way you can get the right answer. Okay, second step, this right here. When you use this calculator, yours might be a little bit different, Matthew. You have to do 59 first, so you have to do 59 sine to get this decimal. So this equals that. So you do 59 sine to get this decimal. There we got that. Then multiply by 37 times 37. You should get 31.7. What? It's the sin one. So 59 sine. Yeah, 59 sine times 37. And you get 31.7. We're just going to round to one decimal place today. So D equals 31.7. Were you able to get it, Matthew? Okay. Okay, and then of course, make sure that that's logical. This length right here should be a little bit less than the hypotenuse, which it is. So we're good. Okay, now we're going to repeat. So we have our designated angle right here. Based on that angle, we have hypotenuse and adjacent. So we want to use this one, cosine. So cosine, since I 70, I just wrote over this number. Cosine of 70 equals adjacent over hypotenuse, so v over 63. Then multiply this by 63. We're trying to get v by itself. Multiply this by 63. 63 cosine 70 equals v. And then once you have this setup ready, plug it into a calculator. I'm going to do 70 cosine times 63. 70 cosine times 63. And you get 21.5. So again, I did 70 cosine times 63. So v equals 21.5. Of course, just make sure that that's logical there. Okay, for the next one, I want you to try it on your own, see how far you can get.
So how you get cost?
Okay, so see how there's nothing here? Don't label that one.
So it's just gonna be the old pay.
Yeah, so that means you'll do 10. Yeah.
Okay.
If you got 48.3, you did it right. Did I get 48.3? Colin, did you get 48.3? Colin, did you get 48.3? Cool. Okay. So, you would have labeled O and A. Kian had a good question. He had labeled the hypotenuse as well, and he's like, well, then how do you tell? Well, you're only labeling the ones that they gave you labels for, and then you can tell. So you have O and A, so we're going to use TOA or tan. Tan of 49 equals opposite over adjacent, so S over 42. And then from here, multiply both sides by 42. 42 tan 49 equals S. Then in the calculator, do 49 tan times 42, 48.3. So S equals 48.3. Okay. The next one, same process. We have a designated angle and then adjacent and hypotenuse. So that means we want to use cosine. Cosine of 75 equals adjacent over hypotenuse. This one is a little bit different because the variable's as a denominator. It just takes one more step to set it up. So what you need to do is to start getting a by itself, we multiply both sides by a. Cosine 75 equals 18. Then divide by cosine of 75 to get a by itself. A equals 18 over cosine of 75. Now, there's different ways that you could do this. In this calculator, it's a little bit tricky. You could do 75 cosine, get the decimal, and like write that down. So 18 divided by 0.2588. A student along the way showed me how to actually do the whole thing in this calculator, so I'll show you as well. You would do 18 divided by 75 cosine, and then hit equal again, and it gives you like the total answer. So it'd be 69.5. So A equals 69.5. Can we show you that again? Okay, so it's 18 divided by 75 cosine, and then hit equal, and it puts it all together. Yeah, so 18 divided by 75 cosine, and then equals, let me get the final. Okay, last part, and this is actually the easy part compared to the rest. For this last part, we're going to look at how to get the angle measure. So in the examples, they'll give us like two sides, and we're finding an angle. So starting over here, they give us some examples just to get used to the calculator. We're going to be finding the angle measure. And the way you find the angle measure is by using the inverse. And where's the inverse on this? Well, if you look behind the buttons, like sine, cosine, tangent, there's sine to the -1, cosine to the -1, and tangent to the -1. Those are your inverses. So to get those, you have to hit second sine to get the inverse. So for these examples, sine of b equals 3/5. You do 3 divided by 5 to get the decimal. And then second sine. And that right there is the angle measure that you're solving for. So 36.9. 36.9. So we're doing second sine for that. What were you saying, Colin? Okay. Oh, yeah, if you type it in wrong, sometimes it will say error because the numbers like that you're putting in wouldn't form a triangle. So for the next one, 12 divided by 25 and then second cosine, and 61.3. For number 3, 1.4825. And second tangent, we have 55.99. I'll just say 56.0. And then this one, 0.9563. Second sine, 72.99. So that would be 73.0. Okay, next page. Putting those two things together. Okay, so on this page, you're going to be solving for angle measure. We're still using SOHCAHTOA, so write that up there, SOHCAHTOA. We're only doing this portion. We're not even going to do the bottom because I know you're probably getting tired. Okay, so for these, we're finding the measure of angle Z. So angle Z on each of those are like designated angle. And then from there, we have opposite and hypotenuse. So we are going to use sine. Sine Z equals opposite over hypotenuse. Then to solve this, you're going to do exactly what we just did. 5 divided by 9. And then second sine. You get 33.7 degrees. And then you might even want to make a note that you're doing second sine, because a lot of students will forget. And then for this one, we have adjacent and hypotenuse. So we need to use cosine. Cosine Z equals 10 over 14. I put a line in the Z because otherwise it looks like a 2. 10 divided by 14. Second cosine, 44.4. And then, of course, always make sure that that is logical. Like these two angles should add to 90, so your degree measure should never be more than 90. And then this one, we have opposite and adjacent, so we gotta do tan of Z equals 5 over 12. We're given 5 divided by 12. Second tan, and we get 22.6. And that's as well. So you have a good amount of time to get your homework done on Schoology. I will enable it. And yeah, let me know if you have